This program deals with successive ionization. This graph shows the energy to remove successive electrons from a magnesium ion. I'm using a logarithmic scale on the left-hand side because the numbers go from hundreds of kilojoules per mole up to hundreds of thousands of kilojoules per mole. The first thing that we should notice, there's a pattern here. As successive electrons are removed, there's an increase in the ionization energy due to the increase in charge of the remaining ion. Let me show you what I mean by that. Once we remove one electron from magnesium, it develops a +1 charge. Now that +1 charge exerts its force on holding on the remaining electrons. Once we remove a second electron, the magnesium ion now jumps to a +2 charge, a greater pull on the valence electrons. There are also some jumps you'll see in the ionization energy that correspond to electrons being removed from different energy levels. The first 2 electrons are easily removed from the 3rd energy level. The next 8 electrons are removed from the 2nd energy level. And finally, the remaining 2, the 11th and 12th electron of magnesium, are the most difficult to remove, coming from the 1s orbital. This graph follows the 8 electrons being removed from magnesium's 2nd energy level a little bit more closely. The first 6 electrons are removed from the 2p orbital. The remaining 2 come from the 2s orbital. You can see here that the 2s orbital is slightly closer to the nucleus, requiring slightly more energy to remove its electrons, hence higher ionization energies than would be anticipated. The patterns that you've seen here in successive ionization are further evidence of the predictive power of the quantum model of the atom. Thanks for watching.